All right, unit 6, lesson number 2. Okay, so looking at this graph, my domain is going to be my set of x values. So it looks like we go from my x value over here is -4 to 7. So I'll write that as -4, 7. My range goes from here, which is -3, up to here, which is 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, I guess. And, 6. We check this guy. That's 5, 6, 7. That's good. -1, -2, -3, -4. Okay, when is it positive? It's positive from -4. Well, be careful with the notation here. So I'm going to use just a parentheses instead of a closed bracket, because at negative, so I'll get it here. So from -5 to 0, we use an open bracket there, united with from here to here. So that would be, again, soft brackets. That would be what, 4 to 7? That would be where it's positive, and then it's negative from 0 to 4. All right, on the next one, the domain goes from here, which is -3, over to there, which is 6. And the range goes from down here, which is -2, up to here, which is +2. And I'm going to, scrolling down is where positive and negative are. I'm going to put those here. So it's positive from -4 to -3, united with 2 to 6. And it's negative from -2 to 2. Okay, so I took care of those up there. Okay, so the domain, it starts from -2 pi, all the way over to there, 3 pi over 2. The range, this is a little tricky on this one. It bottoms out here, I guess. Hard to call the range here because pi is, a little bigger than 3. So let's call this the range. It's from -4 to 4. It's positive from -2 pi to pi, united with 0 to pi. And it's negative from -pi to 0, united with pi to 3 pi over 2. Okay, the next one, the domain, starts -2 pi, ends over at that end at pi. The range is another one where the range is a little tricky to read. It looks like I'm going to call that -3 to 3. It's positive from, open circle. If we just did positives, this would be open. Actually, no, it's closed right there. So that'd be a hard bracket there, 2 pi to 3 pi over 2. And it's also positive from -pi over 2 to pi over 2. And where's it negative? It's negative from -3 pi over 2 to -pi, along with, or united with, pi over 2 to pi. All right, piecewise functions. What we have to do with this is we have to set up branches, I call them. So if we go with y equals, we're going to have two branches. The first branch is going to be from x equals 0 to x equals 3. So x is greater than or equal to 0, less than or equal to 3. And the next branch goes from x is greater than or equal to 4 and less than or equal to 8. Now, in order to get the actual rule for each branch, we have to determine the slope of each segment. So the slope on the first segment, I would take the point 0, 1, which is at this end, and then the point over here, which is what, 3, negative 5, 3 comma negative 5. And if I do my slope formula, 1 take away negative 5 is 6, 0 take away 3 is negative 3. So my slope is negative 2, and I can see my y-intercept is 1. So this would be negative 2x plus 1 for that branch. On the next one, I would take the point 4, negative 1, and the point 8, 0. And if I do my slope formula here, say 0 take away negative 1 is 1, 8 take away 4 is 4. So I know my slope is going to be 1/4 of x. And then I don't really know my y-intercept in this case. I could extend it. We're going down 1 and over 4. So if we went down 1 and over 4, it looks like my y-intercept would be negative 2. And there's my piecewise function. All right, on the next one, number 6, I'm going to take the same approach. I'm going to have a piecewise function. This first branch goes from negative 2 over to 2. So negative 2 less than or equal to x, less than or equal to positive 2. And the other branch here looks like from 3 to 9. Is that correct? That'll be x is greater than or equal to 3, less than or equal to 9. On the first branch, I can see the y-intercept right there is 5. And if I do my slope visually, it's over 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. And 6 over 4 is 3 over 2, so that'll be 3 over 2x plus the intercept, which is 5. That's the first branch. On the next one, I'm down 2 and over 1, 2, 3, 4, 5, 6. So that's negative 1/3 of x. And my intercept is what? I don't know. So I'm going to take, the way I'll do this one is I'll take this point 10, I'm sorry, not 10, 9. Bear with me here, 9, negative 1. With a slope of negative 1/3, right? So I'm going to do y plus 1 equals negative 1/3 of x minus 9. That's point slope form. Y minus y1 is m times x minus x1. So I plopped in 9 for the x value, negative 1 for the y. So that'll be negative. The way I can write this, excuse me, would be negative 1/3 of x minus 9 minus 1. Okay, I could have used the other point too if I wanted to. I could have done the point 3, 1. And then it would have been y minus 1 equals negative 1/3 of x minus 3, which would be negative 1/3 of x minus 3 plus 1. So either one of these works in there. All right, so the next set of problems can be a little bit daunting here with this Ferris wheel. It says the Ferris wheel has a radius of 25 feet. So from the center of the circle out to either A, B, C, D, E, any of those letters is 25. And it's 30 feet off the ground, which means this little piece down in here, this is the ground, that must be 5. It says that the Ferris wheel does a full rotation in 30 seconds. So it goes 360 degrees every 30 seconds, which if we reduce that is 12 degrees per second. So to get from A to B, it would take, what? It's 36 degrees there, so I guess it would take 3 seconds to get there. The reason I know that's 36 is because if I count how many arcs there are, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, each 360 divided by 10 would give me 36 degrees. All right, so it says calculate the height of the rider at the following times after 2 seconds. So if we're going 12 degrees per second times 2 seconds, we'll have rotated 24 degrees. And so my height is going to be y equals what? Now that little triangle there would be, not as it's pictured here, that's 36, it would come out sort of like that. And it would be that little segment from here to here is going to be what? Think about that for a second. It's going to be 25 sine of 24 degrees, right? Now, if I, bear with me a bit because I don't see my calculator. Here it is. Okay, so if I type that in my calculator, it's warming up. 25 times the sine of 24 degrees, I get 10.2, I guess. But that's just this distance above A, right in here. So there's still how much to the ground? There's still 30 feet to the ground. So the distance to the ground is going to be 40.2 feet, because the distance to the ground, like in the case of this picture here, the distance to the ground is this green segment. So I calculate this BA length and add it to the distance to the ground. And the triangle that forms in this case would come out of the center of the circle like this, go up to the Ferris wheel over here, and the angle right in here would be 24 degrees. This is 25 on the hypotenuse, and this letter here, I'll use H for height. The sine of 24 degrees is H over 25, so that length is 25, sine of 24. That answer, the 10.2, is not how high above the ground. It's above this horizontal axis right there. All right, so in this next section, what we're going to do is calculate the height in at different times from 1 second to 30 seconds. So what I'm going to do here first is I'm going to write out the formula, which is y equals 25 sine of 12t plus what? Plus 30. Okay, so the 30, this is the Ferris wheel. The 25 goes from the center to the edge of the Ferris wheel. That's the 25. And then this little piece here is 5. So when we make a triangle here like that, we're going to be taking this length here, the opposite of the angle formed by the center of the circle and the radii spoking out to the circle's circumference. This calculation here will give me the length of, and I'll highlight this segment in red, it'll give me the length of that segment right there. And as I move to different positions, I reach out and come down, I'll have a triangle in each case. So what I'm going to do in all of these is, in case the first one, I'm not going to do every single calculation. It's going to be y equals 25 sine of 12 times 1 plus 30. That's what I don't know if I would fit in here. Very much room there. If you put that through your calculator, you get 35.2. On the next one, I'm going to do y equals 25 sine of 12 times 3 plus 30. Thinking that every 3 seconds I'm rotating 12 degrees, because it's 360 degrees around the circle. We're rotating every 30 degrees, we're rotating 1, so that's 12 degrees per second. So at 3 seconds, that's going 12 times 3, 36 degrees, and I'll get 44.7. So one more time on the next one, y equals 25 sine of 12 times 5 plus 30, and that'll be this calculation, and that'll come out 51.7. And I'm just going to keep doing that all the way down. This next one will be 25 times 12 times 7, 25 times 12 times 8, 25 times 12 times 11. A good way to do this with your calculator, if you were to type into y1, 25 sine of 12t plus 30, you could build a table with your calculator and just see all these values. So going down the list here, the answers are 51.7, 54.9, 54.9. And notice 7 and 8 seconds are the same, and that's because 7 and 8 seconds are mirror images in the y-axis of the Ferris wheel. So if you look down here, see how 9 seconds position D and 6 seconds position C are mirror images in what would be the y-axis if I drew it in. So they have the same height above the ground. Same thing for B and E, A and F, G and J, H and I. Those are reflections over the y-axis. There's also some reflective qualities with E and G. Those are points reflected over the line AF. Okay, so continuing on with these values, it's 48.6 right here, 35.2 right there, 30. That at 15 seconds we've gone halfway around, so we're now at position F, right? Where 3 seconds was position B. When we get back to 30 seconds, we'll be back to position A again. All right, so this is now 24.8. We're now getting closer to the ground here. 8.3, we're still closer to the ground. 5.1, 5.1, 8.3, we're on the way up again. 15.3, and finally to 30. So as we go around, as we rotate around this Ferris wheel, we're going to have duplications of heights at various times. We're going to be rising from A to like we're about here, falling from there all the way down to the ground here, almost to the ground, 5 feet off the ground, then rising back up again. Okay, so it says, what about the positions for 7 and 8 seconds? Now, 7 and 8 seconds, notice they have the same values, and that's because at 7 and 8 seconds, I draw a circle, we're at a circle, there we go. We would be at positions like this and this. Okay, so same height off the ground there. They're just reflections of the would be the y-axis. 14, 15, and 16 seconds would actually be the triangles. Like in this case, this triangle shows up over here like that. So it's reflected over the what would be the y-axis, I guess. Okay, 14, 15, and 16. If we look up here at 14, 15, and 16, 14 is 35.2, 15 is 30, 16. Notice that the difference here between 24.8 and 30, 35.2 and 30 are the same. So what's going on there? That means that on the circle, we're in this position right here, and then we wind up in this position over here. So that's reflected over what? It's reflected over AF. Reflected over AF. And 22 and 23, we look back up here, 22 and 23, notice these answers are the same. 22 and 23 on the circle are sort of akin to H and I here. If I do a picture again, I draw the circle. One of them is like right here, and the other one's right there. So reflected in the y-axis, we'll call it. All right. So just as an aside here, as we go around a circle, if I rotate from here to here, stop, and look at that triangle, if I rotate that triangle over the y-axis, like that, this position is going to have the same y value as that position has, but the x positions would be opposite to each other. Okay, and if I have my circle and I put my positions here and here, this triangle is reflected over the, if this was the x-axis in the diagram, it's AF. So these would have the same x values, right? These 2 points would have the same x values, but their y values would be what? Probably opposites, right? Think about that. All right, so in this one here, number 12, if we establish that all these triangles are congruent right triangles, and they have a central angle of theta, so that I'll put a little blue dot, maybe, in there. That triangle has got a radius here. It's got an angle of theta. And notice that all of those triangles have the same sizes of legs, same angles, and so on. So the question is, describe the relationship between angle theta here and the hypotenuse makes with the x-axis, which is the angle of rotation. So if it's theta from, let me just clean this up so you can see it more clearly. If it's theta by rotation from here to here, here to here to here, and all the way over to here, in quadrant number 2, that's going to be 180 minus the theta in quadrant 2. Because it's 100, or you could put pi, I guess. Because if we do it in radians, it would be pi minus theta. If we go rotate all the way over to this position, then that's going to be in quadrant 3. That's going to be 180 plus the theta, or pi plus the theta. So if it takes you, say 10 degrees to get to this position, and this is also 10 right here, then the rotation from here to here is 180 minus 10, and then the rotation all the way over to here is 180 plus 10. In quadrant number 4, this rotation all the way around to here is 360 minus theta. So let me demonstrate that with a specific angle. So if I come out here, make a right triangle, and this is 20 degrees, then when that triangle flips over the y-axis, the rotation from here to here is going to be 180 minus 20. When that triangle in quadrant 2 is reflected into quadrant 3, the angle rotation all the way to here is going to be 180. Bear with me with my writing. Plus 20. That's going to be 200 degrees. This is 160. And if we then reflect that red triangle over to this position, then the angle of rotation all the way to here is going to be 360 minus the 20, or 340. So that I call this a family. 20 degrees in the first quadrant, 160 in the second, 200 in the third, 340 in the fourth. So if we started with 10 degrees, it's going to be 10 degrees in quadrant 1, 180 minus 10, quadrant 2, 180 plus 10, quadrant 3, 360 minus 10 will be quadrant 4. Okay, so on to some algebra here. All right, so we have a common denominator of 3x minus 12. So we'll do 7x minus 10 minus, and be careful here with your minus in front of a binomial here. So that's going to be 7x minus 10 minus x minus 8 over 3x minus 12. What do we get there? 7x minus x is 6x. Negative 10 minus 8 is negative 18 over 3x minus 12. And I'm going to check the key here because I think that can be reduced or simplified, as you call it. the numerator is what? 3 times x minus 6. The denominator is 3 times x minus 4. These 3's can cancel out. X minus 6 over x minus 4. All right, on number 14, again, we have a common denominator, so it makes things a little bit easier. X squared minus 9. So I'm going to do this a little quicker. 5x squared minus 9x squared is negative 4x squared. Negative 8x minus negative 4x is what? Negative 12x. Now, is there anything I can do with that? I can factor the numerator as negative 4x times x plus 3, taking out the common factor of negative 4x. And the denominator is x minus 3 times x plus 3. Lo and behold, there we go. Those cancel out. So negative 4x over x minus 3. Okay, on the next one, we do not have a common denominator. So I'm going to factor this as 2 times x minus 3. I factor this as 5 times x minus 3, which means my common denominator on number 15 is 10 times x minus 3. So they both have x minus 3, so I need that. And the LCM for 2 and a 5 is 10. That means the numerator up here has to get multiplied by 5. 5 times 3x minus 5. And my denominator has to get multiplied by 2. So, my numerator on the next fraction has to get multiplied by 2. And what does that do? I get 15x minus 25 minus 8x plus 4. What's that? That is 7x. So this is over 10 times x minus 3. So that's 15x take away 8x is 7x. Negative 25 take away 4 is negative 21 over 10 times x minus 3. Numerator factors is 7 times x minus 3 over 10 times x minus 3. Output the x minus 3 is 7 over 10. All right, the next one, unfortunately, the C makes this problem be a little complicated. So the common denominator is actually, now what I would actually do with this one, I would change this to a plus and make this C minus 4. So I'm taking the opposite, and subtraction is adding the opposite, so I took the opposite of the second fraction by negating the denominator. I don't want to negate the numerator as well, because then I won't be, if I negate the numerator and denominator, I won't change the value. So what does that do? That makes my common denominator x minus 4 times c minus 4, which means the x minus 10, x minus 10 in the numerator above x minus 4 has to be multiplied by c minus 4, plus the x plus 2 in the second guy has to get multiplied by what? X minus 4. So there's a little bit of a cross multiply feel on this. Just notice that if I sort of clean this back up again, I've got x minus 10 times c minus 4. That's sort of this phrase multiplied by that one. And then I've got x plus 2 times x minus 4, which is the denominator times the numerator. Now, if I clean all this up, keep my fingers crossed here that I keep all my calculations right. On the first one, I get xc for the first, minus 4x for the outer, minus 10c for the inner, and plus 40. So that's what I just did there was I multiplied these two together. Now I'll multiply the second part together. I get x squared, negative 4x, positive 2x, and minus 8. And this is all over the common denominator of x minus 4 times c minus 4. Now, if I combine like terms, what am I going to get? I've got a negative 4x, a negative 4x, and a 2x. Those are all my x's, right? So that's negative 6x. So I'm going to kind of highlight these like terms. So that's negative 6x. Let's start with that. Do I have any other xc's? I don't see any xc's. So I have a plus xc. And I'll highlight that because I took care of it. And then it looks like I have an x squared. So I'll add an x squared. And what else? I have took care of the x squared, right? So I'm going to highlight that and get rid of that. It looks like I have 10c minus 10c, and I got a 40 and an 8, which is 32. And I think that's what I got. This is all over my common denominator, x minus 4 times c minus 4. For accuracy. Okay, I think that's correct. All right, number 17. I'll box this off a little bit. All right, so what I'm going to do right away here on this one, notice I have an x plus 2, but the denominator in the second one is negative x minus 2, which is the opposite. I would change that to 2x plus 11 over x plus 2 plus 2x minus 3 over x plus 2. So I'm changing basically, my idea here is that a take away b is the same as a plus the opposite of b. So I'm making this a plus sign, and I'm taking the opposite of this fraction by negating just the denominator, which gives me a common denominator, which means I just have 2x plus 2x, which is 4x, 11 plus negative 3, which is 8, over x plus 2. And then if I factor my numerator, it's 4 times x plus 2 over x plus 2. So the numerator is 4 times x plus 2 over x plus 2, which is 4. So number 17 should be 4. All right, I'm going to try the same thing on number 18. I'm going to write 3 over 4 times x, take away 3, factoring this guy. And I see the opposite over here, 3 minus x. I'll make it plus 3 over x minus 3. So that means all I have to do is multiply the second fraction by 4 in the numerator and denominator. And that'll give me 3 plus 3 times 4 over 4 times x minus 3, which is 15 over 4 times x minus 3. Okay. I'm going to check that one more time. So I changed it to what? Plus the opposite. X minus 10 times c minus 4. xc minus 4x minus 10c plus 40. If that checks. And x squared plus 4x minus 4x plus 28. That checks. All right. That's it. All right. So that was unit 6, lesson 2.